Okay, so let's go through the pop quiz real quick. All right, so we're given pKa of 8 for OH and a pKa of the amine. Just keep in mind we're talking about NH3 for pKa, so let's go through the reactions real quick. So at 8, we have OH, H2O making O minus, H3O plus. For pKa 10, we have NH3 plus, H2O going to the base plus H3O plus. These are the two Ka10 and Ka8. Ka10 is the weaker reaction. It's 10 to the minus 10 versus 10 to the minus 8. Kb is going to be 4 for the amine reacting with water to make the conjugate acid. And Kb is going to be 6 for O minus H2O making OH plus OH minus. So O minus at pKb 6, 10 to the minus 6, versus 10 to the minus 4 is going to be weaker. So we know that NH2 is the strongest base because O minus is weaker, and OH is the stronger acid. We know that NH3 plus is weaker as an acid than OH because OH is the strongest. We know that NH2 is a stronger base because its Kb is smaller than O minus. And we know that D has to be wrong because the pKb is 6. And E is correct because that is the right Ka reaction for this. So there were 4 correct answers, 1 wrong. Okay, so in this reaction, we were given a certain amount of Gb minus and given pKa, so let's work through this. But Gp minus is going to react under a Kb because it's the conjugate base reacting with water. So to find OH minus, we need to use the C0 times Kb. To find Kb, we first recognize that given Ka, we could do 14 minus pKa and get Kb, which is 9.3. Kb, so we plug this in, 0.05, 10 to the minus 9.3, and we're going to get the hydroxide as 5 times 10 to the minus 6 molar. pOH for this is going to be 5.3. As many of you noticed in the quiz, it had an error with OH minus instead of pOH, so everyone was given +1 for this problem. Okay, and in the other section, we did the conjugate acid. So let's take, we have GHB, 0.05 molar of GHB is going to be working under Ka, but you're given pKb, so we got to do the same thing as the last problem, which is 14 minus pKb will give us pKa of 4.7. We can immediately write H3O plus is the concentration times pKa. We get 1 times 10 to the minus 3, which if we take the negative log of it, we get pH of 3. Answer D. Okay, so let's look at this problem. Here we have the same molecule, norepinephrine, and so at pH of 9, what state would be the most and the highest in concentration? So we make our pH line. Take the pKa of one of the acids, we take the pKa of the other acid, and then if it's to the left of its pKa, it's going to be in the acidic form, and if it's to the right, it's going to be in its basic form. So as we cross pK8, which is of the OH, we would have the conjugate base as O minus. We still have not crossed the pKa of NH3+, so that's still acidic. Then we cross pH of 10, and we see we have the conjugate base O minus and the conjugate base NH2. The question asks for pH 9, so we should expect to have O minus and NH3+. See. In the other section, we asked for pH of 7. If it was pH of 7, we would have both protonated states, which would be A. Okay, so here we have we're going to use the Henderson-Hasselbalch equation. We have the pH of 4, we have Ka, and we're asking for the ratio. So this works as, so we need to find pKa, and the only thing we need now is to solve for the ratio of A minus to HA. We plug this in, and we can solve for the logarithm of A minus of HA, which is 0.87. We take the power of 10 to both sides, and we get 7.4, which is B. Okay, so this is asked a slightly different way for the other section, which is we have the ratio and Ka, what's pH? So we know the ratio is 5.2, so we just have to plug this in. We know pKa, so pH equals pKa plus log of this ratio. So 3.1 plus the log of 5.2, we do that, and we see that we get 3.8, which is answer D. Okay, so so this question, we're going to switch from 9 to 7 as it was in the exam, but it's very similar to the other problem. We write the pKa's 8 and 10 on our pH line, acid form to the left, base to the right. And so we do that. We look at pH 7, we're in the both acidic form, and we would pick A. All right, so question number 5 asks, is pretty, this is from the packet, one of the first couple pages, and so it's an evaluation of the protons and the nitrogens that are on LSD. So let's take a look. From the acidic standpoint, the base, so we're just organizing our information. A is carbon, hydrogen bonded to a carbon. B is a hydrogen bonded to a nitrogen with a single bond, double bond. And C is a carbon attached to a hydrogen, single bond, single bond. Well, the single bond carbons, this is going to be the least acidic possible. Then A is going to be the next most acidic, with B being the most acidic. So we don't usually think of nitrogens being acidic, but compared to carbon, and with a single bond, double bond, it'll be more acidic than usual. Looking at the bases, we have 3 different bases. So 3 is the one we just talked about in terms of the acid. It's a very stable single bond, double bond, the nitrogen. 2 is a tertiary, carbon, 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 while 1 is going to be a tertiary also, but it has a single bond, double bond, and electron withdrawing group. So we're going to see that 1 is going to be stabilized a bit more with resonance and withdrawing. 3 is going to be stabilized by single bond, double bond. So the most reactive, which is going to be the strongest base, is going to be 2, which is the tertiary carbon without any single bond, double bond. Most reactive, so that places us between B and C. C, we know, is definitely not the most acidic acid, so we would pick B. Okay. So the last question, I believe, or the last couple questions is that, okay, looking at these bases, which one's going to be weakest and which one's going to be strongest? So keep in mind that if we have a nitrogen with a single bond, double bond, it's going to be weak. If we have nitrogen with carbons attached to it with only single bonds, it's going to be strong. And if we have a nitrogen bonded to a carbon with electron withdrawing, it's going to be weak. And then if we have even more carbons, it's going to be very strong. So when we're looking at this, we would say B and A are going to be the strongest, while C and D are going to be the weakest. So we look here, we say D and C are the weakest, and we know that B is the strongest, right? So we only have 2 choices between the weakest. Here, B is the strongest, and so we would pick B. Okay. So the last couple slides deal with reaction shifts for Module 2, so let's do that quickly. So we have to keep in mind the 2 sides of the reaction are going to be, different things are going to happen. This is the case when water is evaporated. So in one section water was evaporated, the other section water was added. So this is the case when water is evaporated. We see the concentrations of all the species would immediately go up. That means the rate forward is going to go up, and the rate reverse is going to go up, but it's going to go up twice as much as the rate forward because there's 2 species present. That was going to immediately allow us to pick D. When we go to the thermodynamic argument, we see the A minus H3O plus, right? This is what's equal to K before the addition, before water is evaporated. The numerator goes up twice while the denominator only goes up once. So Q immediately increases. So the answer here is that the Q would immediately increase, and the shift that would occur to reestablish would decrease the number of moles of product, while the rate would immediately be larger for the rate. The rate reverse would be immediately larger than the rate forward, and it would have to establish by shifting. So both say the same answer, both are correct. If we had to show this by a graph, we would see that Q would initially go up, then would have to decrease. It decreases by shifting products. By reacting products, the moles of products go down and reactants go up. Okay, in this case, water is added, so it's going to be a different story. Still looking at the same species, but we see now because of the dilution, the concentration of HA goes down, everyone goes down. So the rate forward goes down, but the rate reversed goes down doubly. So it means that immediately the rate forward will immediately be larger because it didn't go down as much as rate reverse. So we would pick C. And of course, the proper shift happens with the increase of number of moles in products. So here for Q, we see the same effect. The numerator goes down more than the denominator. So Q goes down. The shift must be, so the Q immediately decreases, and the shift must be to make more, so the Q increases, which means product increase. So we would then pick B. Q would immediately decrease, and then the shift in Q. All right, so this is the end of the pop quiz. Good luck, everyone.